Now we are going to continue about amphoteric. So in chemistry, we have some oxide. There are four different oxides. We have acid oxide, such as SO2. This is acidic oxide. And then we also have basic oxide, such as Na2O. And then we also have neutral oxides such as N2O or carbon monoxide. This is neutral. And we also have amphoteric oxide such as zinc oxide, ZNO, and also Al2O3. So I think it's better if we review a little bit about oxide before we go to amphoteric. SO2, this is the example of acidic oxide. Acidic oxide means when it is dissolved in the water, it will produce acidic solution. And the keyword for this acidic oxide is formed when you have nonmetal with oxygen. For basic, it is metal with oxygen. And this is a basic oxide. So when it's dissolved in the water, it will produce basic solution. And here we have neutral. For neutral means they are not acid and not basic, of course, so they do not react with acid and they also do not react with bases. And there are two common examples of neutral oxide. The first one is carbon monoxide and the second one is dinitrogen oxide. So these two are the neutral oxide. And this is what we will discuss further today. We are going to talk about amphoteric. And that's on the definition, amphoteric is a substance that can behave as either acid and base, depending on what they react with. And amphoteric is very general name. So it cover all substance that can behave as an acid and also base. But when we discuss this topic, specifically when we talk about Bronsted-Lowry topic, we have another terminology that you guys have to pay attention. We call this as amphiprotic. So what is amphiprotic? So amphiprotic is a chemical species capable of accepting and donating proton. So this limited to Bronsted-Lowry. But when we talk about amphoteric, that is a general terminology for all species that can behave as acid and bases, and they are not limited to Bronsted-Lowry theory. And we have to understand which species can be considered as amphiprotic. There are two requirements. The first one, they must have H plus. The first one, they must have H plus. So they must be able to release this. So it will donate the H plus. And the second one, they must have what we call by lone pair. And this lone pair will accept the H plus. Okay, now I'm going to give you example about amphiprotic, and I'm going to use HPO4 2 minus. Remember the basic idea, amphiprotic can behave as acid and base by accepting and donating the proton. Let's use water as the second reactant that react with HPO4 2 minus. I'm going to write the equation here. So HPO4 2 minus react with water the second reaction will be the same. So when you have HPO4 react with water also, and we will use the first equation for acid. Yeah. The first equation will be when HPO4 2 minus act as an acid, and the second equation when HPO4 2 minus act as a base. Is a substance that can donate the H plus. So for the first equation, I'm going to make HPO4 2 minus donate 1 H plus to water. Therefore, the product will be PO4 3 minus. As you can see here, one hydrogen is given to water molecule. So this is when HPO4 act as an acid. Acid is proton donator. And this is for HPO4 act as a base. Base mean can receive or proton acceptor. So they will accepting the proton, and the proton will be given by H2O. So the reaction will be like this. H2PO4 minus 1 and OH minus. And this is when water donate the H plus to HPO4. So in this case, HPO4 2 minus receive. So they are a base because base is a proton acceptor. And once again, if you want to identify whether your species can act as an acid and also as a base, or we call as amphiprotic, by checking two key ideas. They can release an H plus, and they have lone pair that can accept that H plus. So that is the two requirement needed. I think that's all for today. If you find this video useful, please share with your friends so that many people can get benefit from this video. Thank you for watching and see you next time.